Good morning and welcome to the Alabama Section Digital Modes Training. My name is Wayne Reed, call sign Kilo 4 Tango Tango Zulu, one of your assistant section managers, and I'll be presenting this introduction to digital modes. This first presentation is geared towards new hams or ham operators that are not familiar with the digital mode transmissions. In later presentations, I'll be presenting and covering a variety of digital modes in greater depth, from installation through setup and advanced uses. So welcome, and I hope this presentation will help you understand digital modes a little better, maybe entice you to give them a try. There's many to choose from and a lot of fun. The Introduction to Digital Modes course outline, we're going to take you through digital modes from terminal node controllers, audio interfaces, and software TNCs, through some of the software, including WinLink Express, FL Digi, narrowband emergency messaging systems, which is a subset of FL Digi. FT8, which is very popular, is a WSJT software, digital mode for technicians licenses, and also give you a sources listing so that you can find all the software and necessary products. When we refer to digital modes in ham radio, it's a series of audible tones that are generated by hand or by computer and used to modulate an FM, AM, single sideband or CW radio carrier. The digital modes are available for all license classifications, and the audible tones are received by the receiving operator's radio and decoded into usable information by the computer. The CW operator, of course, does the decoding by ear, and the remainder of the modes are decoded by computer or radio software. There's a number of numerous digital modes and associated software that is used throughout the ham radio hobby, and we'll explore several of them in this presentation. The big advantage to digital transmissions comes from the very narrow bandwidth and thus an enhanced signal-to-noise ratio. That means the amount of radio noise in the background compared to the transmitted signal by the opposite end radio station. Digital modes are designed to be used with very little output power and still effectively communicate and get the necessary coding through. That is a CW transmission, and I'm going to take you through several of the digital modes here and show you on the scope the size of the bandwidth and kind of give you an idea how little bandwidth they take up compared to a single sideband transmission. And you also notice the noise on the edge, and that's one of the reasons that signal to noise ratio is so good. This is JT65 mode, one of the SJT software modes, and you can tell by the scope it's about 65 hertz wide, and thus its name. This is PSK31, a very popular mode in digital transmissions. You notice at the top of the scope trace there, it's about 32 hertz wide. Very, very effective for long-range keyboard-to-keyboard communications, very popular.
Thanks for the contact. Whiskey 2, Whiskey Cures.
Romeo, Yankee Sarah, Foxtrot. Yankee, Yankee Sarah, Florida.
Whiskey 0, Yankee, Yankee.
This is a single sideband transmission, and the reason I put this in here is so you could note that it's approximately 2 kilohertz wide, 4 divisions at 500 hertz per division. But what you see is the noise on the top of the transmission. So that's what makes digital modes, as compared to single sideband modes, so effective. So now we know a little bit more about digital modes, and they are a tone generated by the hand of a human or by a computer software program and encoded into a message format that can be sent out over the radio and decode it at the other end and have the information transferred to that operator. So we know what they look like. Let's take a look at the equipment and setup for digital modes. A terminal node controller is a device that's external to your computer and your radio, and it takes serial information from your computer software and it codes that into a specific digital mode that you are using. So after encoding the information, that TNC then engages or transmit push to talk on your radio and sends that information out in the specific format that you have chosen. So at the beginning of the digital development, there was no way for the computer software to both encode the information from the and key the transceiver. So an interim device was developed. And think of a TNC like the original modem you used to access the internet on your computer back in the 90s, except the TNC keys your radio and also can control your radio. The standard encoding with the original TNC was based on the AX25 format. As computers and software advanced, the ability to perform all the TNC functions via software evolved also. Although the software TNC could handle the encoding, there was still a need to interface the computer's audio to the transceiver. The push-to-talk function also needed to be created. So with that, the invention of the audio interface came along, and it is currently available as a standalone unit external to the computer and transceiver, and also the newer transceivers have it built in, so you get the best of both worlds. In this first slide, we see the original TNC as an external device. It takes the packet or software application information and sends that data along with push-to-talk to the computer hardware interface, which happens to be the serial port. And that serial port connects to the TNC in a bidirectional connection, and this TNC takes that data, encodes the audio, and sends it out through the radio, and also pushes to the push-to-talk on the radio, and it transmits the information. On the return side, when the radio receives information, the TNC takes the audio out of the transceiver, takes it in, decodes that information, sends it back through the serial port, back to the computer's application, and you can see the information on the screen. In this diagram, we're showing the use of an external audio interface, and that may be either embedded within the back of the transceiver or in the transceiver, or it may be an external audio interface like a signal link. But as you can see, the packet software application sometimes cannot encode all the information. So a secondary app is used, which is called a software TNC, and we'll be exploring software TNCs in a later presentation. But the packet software or a software TNC encodes the information and sends that information via audio tones to the computer's hardware interface, and in this case it's in the USB. And the USB either sends that information to the embedded sound card that's on the transceiver or an external device, in this case a signal link, and the signal link handles the push-to-talk and the audio in and out and sends that information back to the computer where it's decoded and the presentation is made on the screen. In addition to the hardware and software examples we've shown already, there are digital modes that you can effectively use with just your computer's mic and speakers and your handheld transceiver. And we'll touch a little bit on this later. There's also a number of applications that you can run on your cell phone, either iOS or Android. Now that we know a little bit more about digital modes and the hardware software requirements to use them, we're going to look at some of these specific digital mode software applications. Now, some of these are quite popular and are used a lot in emergency communications, and we will be going into them in depth in future presentations. The first software application I want to discuss plays a key role in today's emergency communications. Today's tech-filled world, the basic means of communications are voice, text, and email. And in times of emergencies, these important modes of communications must be restored as soon as possible. And during emergencies, cell towers, phones, internet are going to be down. So our mobile radios can fill the voice portion of that requirement. However, text and email become essential to our served agencies during disasters. WinLink Express helps fill that void by providing an internet application that is used via HF, VHF, and UHF, and it becomes a EMCOM, Emergency Communications Primary Traffic Source. Uses Windows operating system computer, TNC's audio interface, some cabling, and your transceiver. And connectivity usually comes from a remote station to a repeater gateway, and that gateway is connected to the internet. It can also be connected via HF gateway, and the HF stations are also connected to the internet. The gateway usually has internet access somewhere outside of the emergency area. Station to station or peer-to-peer communications, relay connections are also available. The HF option in WinLink has built-in software. The UHF, VHF packet options require a software or hardware TNC interface to complete the signal encoding. WinLink uses common message servers that are online 24/7 around the world to move messages. The originating stations contact HF, VHF, or UHF or other WinLink gateways to get their messages forwarded to the internet intended recipient. In some instances, the message may be received and forwarded to that recipient at a later time. This is called store and forward. So you can see by the diagram, you've got all of these potential sources and gateways connected to the common message servers. So if you can't reach one on one frequency, generally you can find another one on another frequency and move that message from your emergency situation you're in outside of the affected area to a gateway and get that message sent via email. The WinLink application itself looks like a standard email program that you're used to, with new messages received, a series of settings, and you've got a variety of ways to connect, and I've showed those in this slide on the right hand side in the flyout. But you've got Telnet, Packet WinLink, PacTor, which is a different type of TNC modem. You've got RDOP, which is an open source version. You've got Vera HF, Vera FM, and this entire program will be subject of a separate presentation. I just wanted to familiarize you with this important link to our communications, emergency communications. Yeah, the basic idea of any email program is to get your messages to the internet and then allow the recipient to receive the message and also receive receive the messages sent to you. Access to the gateways that are available are on HF, VHF, D-Star, and even APRS. And also you can have relay stations, gateway to gateway, or gateway to primary mobile stations, and you can store and forward messages that way. Currently, there's more than 15,000 radio users in all classes of licenses and approximately 100,000 internet recipients. Monthly traffic averages about 150,000 messages. The system is in place and it works, and it's a de facto standard for all of our emergency communications, and also it's becoming a great asset to Department of Homeland Security and National Defense. One of the great benefits of WinLink Express is that it contains all the necessary standardized templates, forms, etc., used by the federal agencies and local American Red Cross, etc. And I showed you the pull-down box here for the templates that are available to initiate an email using the standardized forms that are available. Also, these forms are available through a browser on both ends of the link, and that enables the user on the emergency end to print the document and all the information contained therein. One of the primary reasons you use WinLink Express, if you've ever tried to transfer a list of key elements or items from one radio station to another using standard messaging format, it becomes very, very tedious to get all the names spelled correctly, recipients, addresses, call signs, those types of things. So with this, you can create a message in a standardized format, transmit that message, and the recipient can open up a browser and print it locally on their standard equipment. The second application that I want to introduce you to is FLDigi, and that's the name is derived from Fast Light Digital, or FLDigi. It's a software application written by an Alabama resident, David Fries, W1HKJ, and is used throughout the world for not only keyboard-to-keyboard communications, but also for emergency communications in a variety of ways. It's extremely flexible. It's got many configurations, many modes, and it's the second needed program if you're going to do any kind of emergency communications because it is so flexible. It's used for emergencies, station to station, and keyboard to keyboard communications. It's got many, many digital modes. We'll look at those in a second. It can be used in conjunction with several other applications within the suite for emergency system called narrowband emergency messaging, and in later presentations we'll go in an in-depth training in that. It includes the ability to also provide radio frequency and connectivity control, CAT control if you wish, for your radio. It kind of looks a little daunting, a little difficult, but really the basic functions of the program are very easy to learn and set up, and I know you'll enjoy it. As you can see, the FLDigi is basically a keyboard-to-keyboard application. It's got many, many modes, but essentially you've got two horizontal frames in the middle. The bottom horizontal frame is where you will see what you're typing, and in the upper frame is what the corresponding station on the other end of the link is sending to you. And at the bottom, you have a representation of the waterfall of all the signals within the audio bandwidth of your radio. I put this screen capture up of the available modes in FLDigi just as a representation. As you can see, it's one mode is Olivia, and the other flyout panel you see there are all the variations available to you of Olivia, that single mode. So there's many, many modes to choose from. They're all essentially keyboard to keyboard, but you do have a variety of options. I wanted to mention a couple other functions on the FLDigi screen. In the upper left there you'll see the frequency and a small white box. If you were using CAT control of your radio, the frequency would show the frequency on your radio, and in the white box is listening to the receiver, and all the stations that are calling CQ on that particular frequency will show up in that box, and you simply have to just double click one of those stations to respond to them. In addition, in the middle there's a series of buttons called macro buttons, and you can set up repetitive functions on those buttons. For instance, answering a CQ, or a description of your station, who you are, your name, your location. Set up those types of functions, and instead of having to type them, on the keyboard, you can just push that button and load them and send them. An additional function of FLDigi that's very, very important for emergency communications, you can send small pictures across FLDigi using the MFSK64 mode. You can transmit pictures and receive them on the opposite end, so that if you have a very important event going on, you can snap a picture, put it on your computer, send it via radio to the opposite end, and they've got a real-time image of what's going on at your site. The next two pieces of software are used in conjunction with FLDigi, and they make up FLDigi along with FL Message and FL Amp, make up the narrowband emergency messaging system. And it's a companion application. You need FLDigi running to run these two applications. The messages are sent out HF, VHF, or UHF, can be decoded by FLDigi software, and also can be acoustically coupled and used in conjunction with your cell phone, and you could decode the messages on your cell phone. The FL Message application is a series of standardized forms and templates that are used to send organizational messaging to either FEMA organizations, Red Cross, ICS forms, those types of things. You can also send comma-separated value formatted spreadsheets. They're also transmittable. And because FLDigi is mode flexible, these formatted messages can be sent across the country or locally, depending on whether you're using UHF, VHF, HF, local repeaters, or what have you. But they are used by FEMA to transmit messages across the country successfully during times of emergency. FL Amp is a file transfer application, and it is used to send files, single files or multiple files, to single stations or multiple stations at once. You just type in the call signs of the station, and the stations out there are listening. If a message is sent, they all receive it, or one receives it, depending on how you have formatted the message. It uses forward error correction. That means that if a message block is missed because of noise on the signal or something like that, the software recognizes the missing block, since it's sequential, and can request the sending station resend that block so that you have a guaranteed complete message. And the nice thing about it is it does listen on the receive side if you're out there as a receiving station, and it will listen for its call sign. And if a message comes in, even if the operator's not there to record it, the software will pick up the file and save it local to the machine. We've covered a couple of applications that are used primarily for emergency communication work, and of course can be used also for regular hobby type station-to-station contact. They're very flexible digital modes, but I think we're going to try something a little different here and try some digital modes that are use low power, and you can make some long-range contacts with little or no fuss. What you're looking at is the opening screen of the FT8 WSJT-X software. FT8, FT4, JT65, Whisper, and several other softwares, digital modes, are included in the software suite of WSJT-X. On the left-hand side, you'll see the entire scope of the waterfall being received and who's out there talking and where they are located on the waterfall. On the right-hand side is where you have placed your receive block, that the area that you would like to receive in. It varies by the position in the waterfall. So if you went up to a clear spot in the waterfall and clicked, you would have nothing on the right-hand side. If you're clicked in a busy spot, you're going to see a lot of stations. So that's what that's for. In the lower right-hand side is a sequence of events that is going to be the transmit cycle if you answer a CQ from another station. So we'll get into that in the next slide. This particular software was designed for weak signal and sporadic E and to enable short transmissions without a lot of response time. And consequently, there's not a lot of operator interaction except for the enable transmit and logging and those types of things. But if you enable transmit, the next time that the transmit cycle comes around to your machine, you would transmit, as you can see in the lower right, the call sign of the station that was calling CQ, your call sign, and your grid square. The next sequence would be the station would respond and call out your call sign and give you a receive value. That receive value then would be returned from your station with a Roger. That's what the R is for. The other station would give you a Roger, Roger, and a 7-3, and then you would respond with your 7-3, all of which you had nothing to do except push the enable transmit one time. It is a weak signal software program, and you can pick up stations and make contacts and verify those contacts with the far end when you can't even hear the signal on the other end. So it's a great software, and it's very, very popular because we're just now coming back into a solar cycle. So it's been extremely popular for the past 5 years when there was no propagation. So to sum up FT8 and the WSJT software, it is weak signal software. It's got multiple modes that you can use for weak signal transmission and reception. And really the big thing is that it can decode signals that you can't even hear. FT4 and FT8 are most popular, especially during poor propagation, because they are a weak signal. JT65 is included in the suite. It's essentially the same. It just takes about 4 minutes to cycle, and it's a lot longer. That's why the increased popularity in FT8 and FT4. Whisper is included in the suite, and it's a program to determine if your station is being heard and from where. So you transmit basically at 5 watts, and then listen. And as you listen, there's other stations that may respond, but the main thing is that stations that hear your station will put the reception pin icon on a map of the world, and you can find out where you're being heard. So all in all, it's a very popular and very useful piece of software and a great digital mode. So with that, let's move on to find out some of the things that technicians class licenses can do with digital modes. All of the digital modes discussed here can be used by technicians. A technician license class may limit a little bit by band restrictions, but they can be used and enjoyed. Technicians are the backbone of our emergency communication structure. We certainly want the techs to practice and use WinLink in all aspects of FL Digi. You should also remember, though, that on the 10-meter band in HF from 28 megahertz to 28.3 megahertz, you can use the FT8 and FT4, and also a little bit higher you can use voice. But the FT8 and FT4 and the other digital modes can all be used on HF in the lower portion of the band. Just checked again this afternoon on 10 meters within the technician's class, a portion of the 10-meter band, and there was 26 stations on FT8 and FT4, 26 countries, excuse me, that could have been contacted on FT8 and FT4. So it's very viable on 10 meters, especially now as we're moving into active sunspots in the current cycle. There's also digital voice modes, which are kind of a separate item, but the digital voice modes include D-Star, Echolink, IRLP, All-Star, CFM, System Fusion, and Yaesu, and they all can take you to in your handheld around the world. So don't be limited by just FM voice repeaters. Make sure you check out all the options you have for digital voice modes, as some require the internet, and some you can go right directly through the repeater. There's one other mode that I'd like to discuss here before we move on. It's commonly associated with 20-meter band, where stations around the world exchange pictures using slow scan TV. Not so much television live anymore, but it's more picture related. Slow scan TV is available for technicians in several methods, but probably the most common is satellite digital modes. There's many FM satellites, and the techs, of course, can use them. And the most common slow scan television reception is done from the International Space Station as it passes over. You can use your FM receiver, handheld or mobile full-size unit, in conjunction with your computer, to receive and print slow scan television pictures from the International Space Station. A space station is also a great voice contact if you get lucky enough to do that, and you can always contact them as they pass over using APRS, which is the automatic packet reporting system, and that's available to technicians also. And we'll be discussing that digital mode in another presentation in its entirety. I hope this introduction to digital modes has piqued your interest, and you'll explore it and their operation and enjoy the thrill of making your first digital contact. We also hope that you join us in using WinLink and FL Digi for communications during emergency events. It's certainly the easiest and most reliable means of passing traffic between stations for our served agencies, and internationally and nationally if possible, if needed. And we will be exploring WinLink and FL Digi in future presentations. This is K4TTZ. Thank you. Here's a list of sources for digital mode software.